All right, so if we take a look at this example here, the blue graph, y equals g of x. Just as an aside, you should know this already, but let's take a moment to, what's the equation? Let's find the equation of y here. What is the equation? Well, this is a parabola, so you know that this is the vertex form, right? X minus, and you can do p or whatever you want. This is, right? Plus, was it q? So we could actually figure out what the equation for this graph is. Now this is, it looks like from the vertex we go over 1 unit and we go up about a half a unit. If we go over 2, we go up exactly 2. So that is exactly half of what we would normally rise for a normally wide parabola. So again, this is just a bit of review. So it looks like the a value is 1/2. So if we put in 1/2 for a, and the vertex is 0, -1, right? That's the vertex. So we'll go x minus 0 minus 1, 0, -1. So this is the equation of this graph, right? Brackets or no brackets, doesn't matter. Okay, 1/2 x squared minus 1. So that's a bit of a review. We should know that. And that's going to be handy because we're going to examine, therefore, we're going to examine the new graph h of x, which is going to be the square root of 1/2 x squared minus 1. And that's what this graph is going to look like. It's different than a straight line, okay? But there are some things that are super important that we need to remember. And one of the things that we just learned in this class was that wherever you have y equals 0 on the original graph, and again, this is going from an original graph, graphing the square root of that. Wherever you have y equals 0, which is right here on the graph, and y equals 0 over here, and wherever you have y equals 1 on the original graph, and y equals 1 over here as well, those are what points? Invariant. Very good. They are invariant points. That means on the square root graph, those points are going to be on the new graph. Okay. So now, a couple things we need to notice. That's the first thing. The second thing is that we cannot take the square root of a what kind of number? Negative. So this graph right here, which is our y graph, where is this negative? If we look on this graph, okay, I see the blue graph here. The blue graph has negative y values down here. Do you see that? All of these values are between 0 and -1 for the graph here. So if we were to take the square root of values for this blue function, we cannot take any square roots of negatives. So wherever the blue line dips below, or the graph dips below the x-axis, those are negative values. We can't touch those. That's not part of the domain. Does that make sense? Here, up here, okay, anywhere around here, that's a positive y value, right? This, a positive y value. This, positive. 0 is okay, square root of 0. 1 is great, square root of 1. But anything negative is no good. So the graph will not exist in this, whoops, I erased the wrong dot there. The graph will not exist in this region right here. Does everyone see that? In this domain. There is no red square root graph there, anywhere in that section. Okay? We good? Okay. Keep focused. You guys are doing a great job. I see you're really paying attention. That's great. So, remember with the square roots now, we take the square root of whatever value is under here. So, simply, you look at all the y values that make up this blue line. So for example, where's 4? Oh, here's 4. Okay, I should make that in red. But this is the 4 right here, right? Y equals 4. So if I want to take the square root of y, what's the square root of 4? The square root of 4 is 2. So the exact same x value, I just go down to 2. Okay? So this has come from this graph down to 2, the square root. The square root of 4 is 2. Just like the square root of 1 was 1, the square root of 0 was 0. What's the square root of 7? Okay, maybe you don't know that. I wouldn't expect you just to know that off the top of your head. You could probably guess, but let's just be exact here. The square root of 7 is 2.64. All right. So 2.64, square root of 7 here, down to 2.64, which is about there. You see that? Square root of 7 came down to 2.64. Everybody with me so far? Take the y values, take the square root, plot them. Now, something interesting happens here. And I'm going to zoom in here, okay? Something interesting happens here. Whoa, what's that? What's the y value right here? What's this y value of the graph right here? It is 0.5, or about 0.5. What is the square root of 0.5? It is 0.707. So if you took 0.7 and multiplied that by 0.7, you would get 0.5. What's interesting is that the square root of a number between 0 and 1 is actually larger than the original number. So look what happens here. The graph from 0.5 actually is 0.707. So it's actually above the blue line here. All of these red dots were below the blue line here, but this is actually above. And we could do that for many other ones. What's the square root of 0.3? Well, that's 0.5477. So 0.3, right? Y 0.3 right here, the square root is a little bit above. Okay? So I've got this zoomed in. This is going to be tough for you, but if you were to do this multiple times and connect all the points, it would look like this. It would jump above the line and kind of be like a curved line there above the graph. This now would continue on through the rest of the points like this. Okay? So it kind of looked like that. Strange, I know. But again, we're taking all the y values, taking the square root, and plotting that new point on the same vertical x. Okay? Because literally, blue is the points x, y. Red are the points x root y. That's what we're plotting. The square root of y, the function y. Over here, same thing. Now don't be afraid, again, don't be afraid of these negative numbers. Okay? Because some students think, oh, I can't go over into the negatives here because you can't take the square root of a negative. It's no good. No, no. It's just the square root of the negative y values. So you have to stay away from this area here. That area is no good. Those are the y values. But look, the blue graph has positive y values over here. So the same thing goes. Square root of 0.5 is 0.7. Connect the dots like this. Zoom back out. And the square root of 4 right here is 2. Put a point. The square root of 7 is whatever that was, 2.6 something. Put a dot. So it looks kind of like this right here. Okay. It's symmetrical to the other side, but it's a bit of a strange shape. And again, there is nothing inside here between this x-intercept and this x-intercept. There's no points for the graph. It's two separate arms. Okay? We won't worry about an equation for this red graph. I just want to show you how to graph that. Okay? Something strange. Now, I'm going to pop over to Desmos again, and I'm going to show you how the parameters work and what it graphs like. And we'll talk about a couple more situations, and then we'll see where we go from there. Okay. So if we go back over to Desmos here, you'll notice, and again, just put your pen down and watch, but I have y equals x squared. Now k here is 0, so I've got over here y equals x squared minus k. Okay? I could have put plus k, but I don't know why I put minus. Anyways, let me put plus here just to be consistent. Plus here, and then I got to go plus over here. Okay, plus k. All right, so we know that if we move k here, the parabola goes up, right? That's the vertical translation. Good? So let's go back down to 0. Okay? And I'm going to bring this down now to -1. Okay, so that's roughly the same now. It's a different a value and everything, but this is roughly the same as the graph. So over here, I'm going to light up here now the square root of this exact same function. And look at what it looks like. Okay, now that's what we just graphed, and if we examine this closely, y equals 1, okay, is an invariant point that's on both graphs. It's an intersection point. and y equals 0 invariant point all over the place. See that? The square root of 0.5, where's 0.5? About there, the square root of 0.5 at 1.225 is going to be 0.707 or so. Okay, right around there. It's larger. The square root of 3, right here, is about 1.73. Any questions about that? Oh gosh, that's the wrong button. All right. So what happens now? Watch this. I'm going to move both graphs at the same time by moving k. So look at what happens when it comes up closer to the x-axis. The vertex comes closer to the x-axis. Whoa. That's what it looks like. That's what it looks like when it's at 0. Now, what is this green graph? The green graph now is y equals the square root of x squared. What's the square root of x squared? Well, it's kind of x, right? It's actually plus or minus x, which is the definition of absolute value of x. That's crazy. Isn't that crazy? Maybe it's not crazy to you, but so if you have a parabola that has the vertex on 0, 0, the square root of that parabola is y equals absolute value of x. Okay? So, again, look at what happens when I move it down. All these same characteristics hold true. 0, 1, and all that. Okay? What happens if what happens if this graph, whoops, I don't want to change h. What am I changing h for? What happens if this graph goes above the x-axis? Now watch carefully. I'm going to zoom in here. This is going to go above the x-axis, so we know that when the vertex is at 0, that's an absolute value function. Watch this. Whoa. Oh, I know. What? How does that work, hey? Well, what's the square root of 0.5? We said it was 0.707. So look at that. That's above. Okay? What's the square root of 1? 1. It's invariant point. There is no 0, so there is no 0. That's obvious. No 0, so there's no 0. Okay? So again, you take the square root of each point and plot its square root for the new value. It just so happens that it kind of starts to look like this a bit. Okay. Now, watch again. I'm going to move the original parabola up even more, and there's going to come a point somewhere here where, look at that. What's the square root of 1? 1. It's an invariant point. Still is. Always has been. What's the square root of 4? The square root of 4 is 2. Right there. Okay? All right. Now, are you ready for this one? I'm going to move the parabola up even more, and look what happens. The square root function sort of shadows this one here like this. It's not a parabola per se, but again, take every value, and you take the square root of it, and you plot its point. Square root. Let's move it up to 4. So the square root of 4 here is 2. Okay? So this kind of levels out a little bit, doesn't it? It's kind of weird shape, isn't it? All right. So that k changes. The graph changes drastically. Remember, no graph where we have negative y values. Okay, let me know if you have any questions so far. Any questions? Okay. Now, you don't have to memorize what the graph looks like. It's a good idea to have an idea of this. But you can easily calculate the graph here. There's a few important key characteristics here. There's absolute value there. There's where, we have a little bit of an overlap here. Crosses over. Okay. All right. Understando? Okay, a couple more examples here. What about this bad boy right here? Okay, this is the real test right here. Draw something similar to this. Just sketch it out. Doesn't have to be the same at all. Just draw something similar. We're going to sketch the square root of this nasty function right here. Yeah, no, we can do it. Totally. All we got to do is pay attention to our important characteristics and the important invariant points, and know what square roots are. That's it. Plot anything. You're not feeling confident with this right here? I'll give it some time. All right. Now, it doesn't have to be exactly like mine, but again, it's going to, if it's something close, then you'll be able to mirror what we're doing up here. Okay, with this graph, the first place you want to start is you know that the square root of 0 is 0. The square root of 1 is? Okay, that's a good place to start. So where is, on this black function, we're going to plot the red square root, y equals 0 is right here. So let's go along the y equals 0 line, that's the x-axis, and these are invariant points right there, right here, invariant point over here for 0. Got it? That's the easiest thing you can do. Just go to the x-axis, which is y equals 0, find out where the graph crosses that, if it ever does, invariant point, invariant point. You know it's got to go through there. Okay? Here's important. This is important too. Look at these. This is where the y values are positive. So this is where the red graph is going to exist. Here and over here. Okay? The red graph is going to exist over here. The red graph is not going to exist in this region where the y's are negative. See that? So there's going to be nothing in this whole region right here. No graph, not allowed. Comprende? See?
Formula.
See, formula. What does that mean again?
Let's go.
Something in Portuguese? Oh yeah, let's go. Let's go! Formula. Okay. All right, what about, where is there another, I thought there was another invariant point. Where else is it?
1.
What? Thank you. Y equals 1. Very good. So y equals 1, I'm going to go, wherever the graph is along y equals 1, I'm going to put a point there too. And way over here. Don't miss any. Okay? That's where you start. Okay? Now, let's start piecing it together, the rest of this mystery here. And I would go to some known values. So like y equals 4, you know that that is y equals what? The square root of 4 is 2. So you go down and you put a point at 2. All right? Put a point at 2. Now, if you know what the square, if you want to figure out what the square root of 3 is, I think we said it was about 1.7. You put another point there. Okay? This is where the graph is 3 down 1.7. So on. Okay? Where is it also 4? It looks like it's 4 over here as well, so that square root is 2. What? 1, 2, 3. Okay, 2. I think this red line of mine is actually just a bit high, sorry. 1, 2, yes? Okay. What? Did I hear you say you're lost? Yes, you did. You said you're lost. Okay. Square root of 4 is? 2. Here's the y equals 4. So now we put y equals 2 right here. That's where 2 is. So you put this point, comes down to there. Okay? Don't worry, you're not lost. I know exactly where you are. Okay? That was supposed to be slightly funny. You can laugh. That's okay. Everybody's nervous. I'm going to die. No, you're not. You're going to be fine. Okay, square root of 3. 3, we said it was about 1.7, so plot her down there. Okay? About there. All right. Okay. Oh, wait. Square root of 0.5 is? 0.707. So look at that. It goes above the line just a little bit. Just a little bit. Square root of 0.5 here again. Yeah, that's 0.5. So the square root is up there. All right. Awesome. Same thing over here. Do I put the dot here below the line? No. If it's between 0 and 1, I put the dot just above the line. Because the square root of numbers between 0 and 1 are actually greater than those original numbers. So, now what you do is start to kind of piece together, little bit by little bit. This might be a little tough for you to draw, but this has got to pop just above the original function there, because the square roots are larger between 0 and 1. Then you just go ahead and sort of, with a smooth curve, try and connect the dots, because the square roots in between the known dots here are going to follow the same sort of pattern, right? And you know what I mean? You just kind of keep connecting the dots, okay? So it looks something like that. And again, we want to cross over the original graph a little bit to go through this one down to 0. Now, do I keep going down here? Ooh, back it up, back it up, back it up. These are negative values down here, so this is bad. Nothing down here, there is no graph. Yeah, pretty much disgusting. It's mathematically disgusting, that's right. Sure. So, I skip this region. It's a big, long jump. I just skip it. Those points are not part of the graph, okay? I go over here, and I know 0, I know 0.707, I know 1. So guess what? Make a little bit of a loop-de-doop there. Yeah. Now, this is really messed up actually over here, so let me just do that again. Okay, so these dots are a little exaggerated, okay? But you got to make a smooth curve. Now, here I probably should have put a few more dots here, because this might have to kind of bend down a little bit and then go up a little bit here or whatever. But if you piece more and more dots together, you're going to get the curve. Okay? I heard you say this is too much. It's not too much. You can do this. You can do this. Now, listen, there's probably about 5 new things here, yeah. Okay? They're all related though. All right? And if you jotted down these examples, you'll be able to go back and look at this, and as you move through the practice questions, you'll be able to, the lights will just start coming on, and it'll be like, oh yeah, I get this. There's so much drawing? Oh, poor you. Okay. Okay, we went over this one already, but watch this carefully. This one is easy. Parabola that's above the x-axis. Simply take the square root of each of any of these numbers. So that's square root of 9 is 3, square root of 4 is 2, so on. 9 is 3 over here again. So this one looks kind of like this, right? Remember we did this on Desmos? Okay, kind of like that. Very uninteresting. But, all right, boys. Okay, any questions about that one? We kind of went over this one already, right? You copying it down in time? Here's our last example. What if you have a parabola that faces downward, okay? You don't have the arms of the parabola above the x-axis that look like this, but the part that's above the x-axis is this little dome part, okay? It's a terrible parabola, I apologize, but it's something like this. So, if this is 1 and this is 0, I know that I have some invariant points at 1 and 0. Great. Now, this is negative, bad. No graphs over here. Nothing over there. The graph is all now between this point and this point. If this is 1, the square root is 1. If this is 0.5, we know the square root is what? About 0.707. So we know that this is what the graph looks like between 0 and 1. Okay? Something like this. And again, apologize for this is a poor drawing. But, watch this. Boys in the back, I want one of you guys to give me the answer. What is the square root of 1.3? Go. Because this value right here is about 1.3, I'm going to say. What's the square root of 1.3? Sorry? Okay, so the square root of 1.3 is less than 1.3. It's 1.1 or so. So 1.1 is about here. So again, we have this sort of strange crossover thing happening. If we were to piece more points together, it would look like this. So literally, if you have, even a half a circle or something like that, well, let's not stick with circles. Let's not go to circles. If you have some kind of parabola, the square root is this behavior, up and then under and then up again. So it kind of looks like this. And I'm going to show you this on Desmos, okay? So let's go over and show you on Desmos what this looks like. We have to change just a few parameters. We have to reflect that parabola about the x-axis, which of course is a negative what value? Reflects this way? A, thank you very much. Negative A value. So let's go over here. Let's change this to a negative. Boom. And where should I put the negative here? Ooh, outside, inside, what? Oh, what if I do this? No good. What if I do this? No good. No good. Let's bring that k value up. Does that look right? Nope. So the negative is not out here. The negative would have to be, let's see, I think it'd have to be in here with some brackets. like negative, oh. All right, so here we go. This is the square root function here. You see that? So if we move k around, that's what happens. Now look at this. We've got a little halo there. Isn't that cute? Okay. What happens if the entire function is in the negative realm? Boom. Square root is undefined. No square root. The red graph has to be above the x-axis. It has to have some positive y values in order for this to happen. Got it? Okay. Look at this. Y equals 1, invariant. Y equals 1, invariant. Y equals 0, invariant. So on. Okay, how many of you have now a 5 out of 5 understanding on what I'm talking to you about today? Give me a 5 out of 5. Anybody? Not very many. Okay. How many of you are solidly above a 1? Solidly above a 1. There we go. Only a few more hands. Come on. So some of you are 0 out of 5 right now, or at 1 out of 5 for understanding. Doubt it. You're lying to me. All right. Here is your big fat assignment right here. 2.2. Right there. Let's make that a little more visible. Okay, you go ahead and copy that down. Show you a little textbook here. All right, so here's your key ideas there in your textbook on page 85. You can take a quick look at those. And you have your assignment up on the board. And here's your textbook. You guys didn't copy that down? I'll give you enough time.
No.